And then there, check 1, 2, 1, 3, 5, 7, 9. It is a math episode after all. Hello and welcome to the STEMPunX Podcast. My name is Joe Garoutte and I will be your host as usual. And I have my buddy STEMBoT here, but he is a little different this time, aren't you, buddy?
I am Joe.
STEMBoT, you have a different quality to your voice.
Well, we have an expansion in our software. Now we're using Davinci Resolve, and it makes me so much more expansive.
Yeah, you'll end up a little hard to deal with, I'm afraid. It sounds wonderful, STEMBoT. Hello, everyone. As you could hear by the beginning, I have a little bit of a math theme going on here, but today we're just going to have a conversation, Michael and I, because our interests in this topic were so varied. So enjoy the episode. It's a little different format, but we hope you like it. Let us know if you have anything to contribute.
Welcome to STEMPunX.
Welcome to STEMPunX. STEMPunX is a bi-monthly podcast intended to bring science,
technology,
engineering,
Math.
straight to your ears from our STEMPunX studio. Hang on, we'll take you for a ride that includes a whole lot of fun and a little bit of education on the side. Stay tuned.
Nice to be in orbit.
Math is a universal language. Every culture utilizes math, so that's one way that people can communicate completely across the spectrum.
Math is the language that scientists use to communicate across language barriers.
The reason that we got started on all this was because Beck called you, right, and had a trigonometry question?
Yes.
And so were you... Nothing like having a robocaller call right in the middle of a recording. So Beck called you and asked about trigonometry and wondered if you could help, right? And so you said...
No.
Because you don't know what trigonometry is, or what?
Because I don't think I know anything about trigonometry. And that's an important distinction.
And she's taking a trigonometry class in high school.
She is.
Yeah. So, STEMBoT, will you define trigonometry for us, please?
Trigonometry is the study of triangles and the lengths and angles of their sides.
So what's cool about trigonometry is architects, draftsmen, engineers, and virtually every field use trigonometry. It's used by pilots, it's used by chemists.
Even game developers.
Even game developers. I was about to say that.
I know. I took the words right out of your mouth on purpose. You know, and that's one of the reasons that I thought that it'd be fun to do this episode is because I see the use of coding coming into the schools. You know, the 8-year-old twins are doing coding classes, or at least moments of coding during class, and then they come home excited about it. STEMBoT, would you include a couple of links in the show notes for some of the coding websites?
Sure, Joe. Anything that helps kids learn to code.
Thanks, buddy. And what they do is they go onto these websites and they can very simply create programs. So they're coding these programs. They love Minecraft. They're crazy about Minecraft, so they go and do that. So you know, the fact that the people who created the coding website used the math that led them to be able to visually create this new piece of software as 8-year-old kids is fantastic.
So I'm not a coder. What kind of math are they doing?
Well, you know, the language that is utilized within the computer is long and complicated for an 8-year-old mind to go and try and repeat. So basically what they do is they put individual strips of code into a visual element that the kids are able then to put together. So, for example, they can create a character, something that represents a character, and then have a bit of code that says move forward. And when I was in school, we were learning BASIC, and we had to type if, then, etc. And now they can do it visually. So they can say move forward, if you hit a wall, then turn right. And they can see all those words within
How's
the
that
program.
math?
The math is within the workings of the coding itself.
So the math is already created for them. They're just using language to create something.
Correct. Yeah. It's been created already. So if you break it all the way down to its elements, somebody originally took all those ones and zeros and associated them with letters So if I type the words if for an if-then statement, the letter I has a binary number. The letter F has a binary number. Those two together represent something to the computer that we see visually the word if, but the computer has it represented as 16 digits that are ones and zeros.
Did we already say something about math being a universal language?
We did.
Which indicates that no matter what language I'm doing this coding that the kids are doing in, it's all broken down into ones and zeros somewhere, which makes it universal. Whether I say if in English or if in Chinese or anything like that, it's still the same ones and zeros.
Yes, and that's the point. So the language that all computers speak is ones and zeros.
Right.
And the visual part of that happens to be in English or Chinese or whatever language somebody's coding in. So then if you take that up one step further, somebody has then taken that and put it into a visual something that a child or somebody who's not very familiar with the way that the code is written ends up being something that they can manipulate and create a program from.
So one of the things that this leads to is that it's so universal that it's a way of describing even things in nature, right? Math is.
Yeah, absolutely.
And which takes us back to earlier episodes.
Right. When we did the bee episode, for example, there was math involved, but we didn't talk about it. The bees create their hives in perfect geometric hexagons, right? When we did the ocean cleanup episode, the waves that are in the ocean can be described through trigonometry.
And that's one of the things that I saw on a website was that ocean tides are described with trigonometry because there's a time factor in that. There's a factor about how far the water comes up onto the beach. All of those have to be
factored in with math equations.
Right.
Yeah.
Another thing that I saw was there's a mosque in Córdoba, Spain, and STEMBoT can put a link to that.
Okie dokie, Michael.
They were using math, trigonometry, to build this mosque by finding the hypotenuse of a triangle. When they stand it up, it then makes the next level of this building equal to the first level, etc., etc. I mean, it's in the science or the math that I've seen on
That's
this.
another one we'll have more links to in the show notes, yeah.
I'm skipping ahead. They won't notice.
So what you're saying is that the zero came in about the 5th century, and then 600 years later, it was adopted more widely. But prior to that, in prehistoric times, they found tally marks in bone. So obviously math has been around for a while, and then zero, when it became something that was used, revolutionized math. So beyond all that, without getting into a complete history lesson on math, because we wanted people to stay awake during this podcast, one of the things that had occurred to me was the question that I asked you earlier. When you have a problem that you need to solve, you don't know if it's trigonometry or algebra or whatever, what are some of the ways that you can solve that problem? There are apps. Big shocker. There are apps that will help you do that. I used one the other day when I was trying to cut a particular board and needed to utilize the Pythagorean theorem, which I understand is, if I wanted to calculate the length of one side of a triangle, if I know that one side is 3, the other side is 4, by doing the math on that, the third side is 5, and that is a perfect right triangle. And I needed to know that third side. Well, I didn't have the math skills to do that. Admittedly, I am very weak in math. But I have an app where I could literally draw out that equation on paper and take a picture of it with the phone, and it solved the math problem for me. So I was able to figure out how long I needed that third board to be to create a right angle.
Because the answer wasn't very simple like 5.
Correct. Because, it's a squared plus b squared equals c squared. And I knew that in my head.
As soon as you say something like that, my head goes like, whoa, wait a minute.
I know, me too, and that's crazy. I know that for me, I didn't see the application of math in school. I mean, I went, okay, fine, I've got to complete a test, I've got to score well on that, and then I checked out. And I only did as much math as I had to. Matter of fact, when I went to college, I chose to get a Bachelor of Arts instead of a Bachelor of Science because I didn't want to go through the math. I chose to learn Spanish instead of doing math. And so far, that has served me better in my field. But here we are in a STEM broadcast. And the reason there's an M on the end of it is because of math. And math is necessary for people who do the E in engineering, the technical side of things, and certainly used in science. So we need math.
I mean, anytime I travel up to Canada, or I'm going to go to Europe in a few months, every time I read a map of Europe, I have to go, well, how do I convert miles to kilometers or kilometers to miles so I can understand how far I'm driving or going someplace? Fahrenheit to Celsius. This is a great place to go because it's only 12 degrees. And I think, okay, what's 12 degrees to me? You know, I can figure out zero really easily.
And that's why it's great that there's an app for that.
Right. Yes, absolutely. Absolutely.
But, you know, the other thing that occurred to me for a math episode, algorithms. We hear about algorithms all the time, and algorithms are present on the internet constantly. We're dealing with them in every single moment that we interact on the internet. Some algorithm somewhere is either finding something for us, tracking our movement, calculating which ad we see, and that's all math.
And I use that word a lot when I'm talking to people about they're tracking us because they're using this algorithm that does whatever, and I'm merely using it as a word.
Don't know exactly how it breaks down.
Right.
Yeah.
Not at all.
Yeah.
But there is something in there that's literally designed by mathematics to do a search on something, for example, right?
And put the right information in front of you.
Right.
Or give your information to somebody who can target you for advertising of some kind.
Right.
Yeah, absolutely. And in its simplest form, you can say that it's math because all of the computers are communicating with ones and zeros. And so in that regard, it is definitely a math equation on some level.
Yes.
The other thing that occurred to me was that it would be pretty fun to include some simple math things that people didn't even know they needed to know. So let's do some of that.
All right.
So are you sure you want to record this? That dribble I was just saying out loud?
Dribble. Let's talk about basketball.
Well, you know, so what Michael and I were talking about here was the fact that I read this thing about the way that they used trigonometry, and they actually did a 5-year study to study how people shoot a basketball, and they studied the free throw, because the free throw is the uncontested shot. Well, in studying free throw after free throw, they determined that actually taller people had a better opportunity for making a free throw. They determined the angle that it needed to be released and the approximate speed. And then they went so far as to determine that it had to cycle at 3 hertz. Now, 1 hertz is 1 cycle per second. So they determined it took about 1 second to get to the hoop. And if that ball turned backwards 3 times, so that would be 3 hertz, then that was the optimum. After that, it didn't help anything.
When you talk about hertz, I immediately start thinking about sound.
Exactly.
Only sound.
And electricity, because electricity is 60 hertz.
Right.
Hertz is a unit, which is a cycle per second of whatever it is. You and I could hand clap at 3 hertz, which goes to the fact that we actually are using math constantly, and we just may not realize it. So, you know, one of the things about utilizing math is that we may not realize that we're very, very good at making a lot of complicated math equations all the time. You know, for example, we manage our money, or at least we try to manage our money. Right. You know, we can make change. At least most people can make change. We balance our checkbook. I know. It's kind of a dead art. We balance our checkbook. We shop for the best price. We prepare food. In baking, we have to make different calculations of how many cups or half a cups or doubling the recipe. Or baking is a science, and we're going to get to that because we're going to do that on a future episode. I definitely am going to delve into the science of cooking in all forms, but baking is going to be a big part of that.
That's a good one. Stay tuned.
So let's go back to this. So, you know, as we were digging through a little bit, we wanted to try and find out some ways that either some trivial things that might be kind of fun to know or some things that you may be able to utilize on a daily basis. I wanted you to be able to just walk away with a few thoughts. You mentioned, Michael, earlier about not being able to convert Celsius to Fahrenheit easily. Well, lo and behold, folks, we were able to find that on the internet. Big shock. And there is an easy way to do it for those of you who are curious. If you take the number in Celsius and you double it. For example, let's say we're going to look at 32 degrees Celsius. We just double that number, and then we add 30. And so our number ends up being 64, 32 times 2, plus 30, which gives us an equivalent of 94 degrees Fahrenheit. So 32 degrees Celsius may sound cold, but it's not. Now, many of you out there probably already know that. I didn't know that math.
I mean, when it gets into the 30s, it's harder for me to get it straight into my head.
But now, instead of looking at something where it's 50 degrees Celsius somewhere and thinking you're going to be comfortable, you're going to say that you're not going to go there because it's hot as Hades.
Right.
Yeah.
Exactly. I don't want to go when it's 94, but I do want to go when it's 12 times 2 plus 30.
54.
54.
Yeah. You know, as we were talking about where math is kind of a universal language, one of the things that we were reading about was that words that we use are kind of, they're handholds, and they help us hold on to thoughts. And when we are talking about math, we have number words that we use, right? They can be written with symbols.
It's a simple thing. When we say something is empty, that zero comes into your head without even thinking about it, right?
Right.
You know, when we say there's a quantity of something, then we start thinking in numbers immediately.
Right. And it does give us a way to absolutely know the amount that we're talking about.
But when we say what's the shape of something, we might not immediately think geometry.
True. And that would be the thing that we could help everyone recognize, is that structure relates to algebra, shape relates to geometry, chance ends up being statistics, like our basketball free throw,
Right.
and change points to calculus. So that helps kind of categorize it. You notice trigonometry isn't in there, Michael, so you may still be hung out to dry as far as what your definition of trigonometry is. Of course, we have that. STEMBoT gave us that earlier. Yeah.
And the takeaway from this is that I'm starting to think of things in a different way, using the language of math instead of saying, gosh, I don't understand. I really am learning a new language in many ways. Is there a possibility or a probability that we're going to be done now?
I think there is a good chance, the statistics are high, that this will be the end of the episode. If any of you have anything out there that you'd like to see us do as a future episode, please send in your suggestions. You can hit us up on Facebook. You can find us through our Patreon page. You can send us an email at STEMPunX@gmail.com. It's time to say goodbye, STEMBoT.
Goodbye, STEMBoT.
Thank you for listening to the STEMPunX Podcast. STEMPunX is sponsored by Córdoba Creative. When you calculate everything that Córdoba Creative can do, you'll realize that they are way more than the sum of their parts. See how they add up at CórdobaCreative.com. And as always, we want to thank all of our fellow STEMPunks on Patreon. We couldn't do this without you. Patreon is an easy way for anyone to contribute to the show. If you are a regular listener but haven't joined the team, head on over to patreon.com/STEMPunks to get in on some extra perks. And by the way, we have some more exclusive content planned for next month's episode. Patrons, it's all because of you. Please spread the word. Thanks again for listening. I don't understand the point you're trying to make. I think we're getting lost here. So,
But
I was agreeing with you. So obviously we're going to have to edit the shit out of that. So you said, so this is where I was going with it. Is that
edit the shit out of that without the word shit.
we're going to have to edit that heavily.